Hello everyone, welcome to the Chemical Safety Technology course. I am your instructor, Suo Yanbo. In this session, we will explore the classification of pressure vessels. Before studying the classification of pressure vessels, let's first watch a video. Delicious meals always fill you with happiness. The joy of the amusement park grows along with the flowers. Going out for shopping reflects the children's filial devotion. Climbing high and looking into the distance, everyone experiences the civility of the modern city. Did you know that the gas cylinders used in cooking the amusement park, rides that bring us joy, and the elevators that make our lives more convenient, all fall under the category of special equipment? So, what exactly is special equipment? According to the regulations on the safety supervision of special equipment refers to boilers, pressure vessels, including gas cylinders, pressure pipelines, elevators, lifting machinery, passenger ropeways, large amusement facilities, and special-purpose motor vehicles used within sites, factories that involve life safety and pose significant risks. Based on their primary operational characteristics, special equipment can be classified into pressure-bearing special equipment and electromechanical special equipment. Pressure-bearing special equipment refers to sealed or tubular equipment that withstands a certain pressure, including boilers, pressure vessels including gas cylinders, and pressure piping. Electromechanical special equipment, on the other hand, refers to equipment that must be powered or driven by electricity, including elevators, lifting machinery, large amusement facilities, passenger ropeways, and on-site factory motor vehicles. Please take a close look. What are the characteristics of this special equipment? We find that some operate under high temperatures and pressures, some run at high altitudes or high speeds, and some contain flammable, explosive, or toxic substances. Therefore, special equipment is characterized by high temperatures, high pressures, high altitudes, high speeds, and the presence of flammable, explosive, or toxic substances. It is equipment with potential hazards that is widely used in people's production and daily lives. Once an accident occurs, it can result in serious personal injuries and significant property damage. From the above discussion, we have learned that pressure vessels are classified as special equipment. So, what exactly is a pressure vessel? According to the regulations on the safety supervision of special equipment, a pressure vessel refers to a closed device designed to contain gases or liquids under a certain pressure. Generally, a pressure vessel is defined as a vessel that meets all of the following conditions: a maximum working pressure of 0.1 megapascal gauge pressure or higher, an internal diameter of 0.15 meter or greater, and a volume of 0.025 cubic meter or greater, and a medium consisting of gas, liquefied gas, or a liquid with a maximum working temperature equal to or higher than its standard boiling point. It is important to note that the design, manufacture, welding, and assembly installation, modification, maintenance use, and inspection of pressure vessels must strictly comply with the provisions of the technical regulations for the safety supervision of fixed pressure vessels. Pressure vessels are required in chemical production processes to store, process, and transport large quantities of materials. Due to differences in the state of the materials, their physical and chemical properties, and the process methods employed, a wide variety of pressure vessels are used. To facilitate safety, supervision, and management, pressure vessels are classified based on their working pressure operating principles and the nature and severity of their hazards. First, pressure vessels are classified into 4 categories based on their working pressure: low pressure, medium pressure, high pressure, and ultra-high pressure. Low pressure designation L 0.1 megapascal is less than or equal to P and Lieutenant 1.6 megapascals. Medium pressure designation M 1.6 megapascals is less than or equal to P and Lieutenant 10 megapascals. High pressure designation H 10 megapascals is less than or equal to P and Lieutenant 100 megapascals. Ultra high pressure designation U 100 megapascals is less than or equal to P is less than or equal to 1000 megapascals. Second, based on their functional principles, in production processes, pressure vessels are classified into reaction vessels, heat exchange vessels, separation vessels, and storage vessels. 1. Reaction vessels, code R, pressure vessels, primarily used to facilitate physical and chemical reactions of the medium. Examples include reactors, reaction kettles, decomposition towers, polymerization kettles, high-pressure kettles, ultra-high-pressure kettles, synthesis towers, copper washing towers, conversion furnaces, cooking kettles, rotary, spherical digesters, autoclaves, and gas generators. 2. Heat exchange vessels, code E, pressure vessels, primarily used to facilitate heat exchange between media. Examples include shell and tube waste, heat boilers, heat exchangers, coolers, condensers, evaporators, heaters, sterilizers, dyeing vats, steam frying kettles, preheating kettles, steam dehydration machines, electric steam generators, and water jackets for gas generators. 3. Separation vessels, code S, pressure vessels, primarily used to achieve fluid pressure, equilibrium, and gas purification and separation. Examples include separators, filters, oil collectors, buffers, scrubbers, absorption towers, drying towers, steam distributors, and deaerators. 4. Storage vessels, code C. Spherical tanks are designated as code B. These are primarily pressure vessels used to contain raw materials such as gases, liquids, and liquefied gases for production. Examples include various types of storage tanks. If a single pressure vessel performs 2 or more process functions simultaneously, it should be classified based on the primary function in the process. Third, pressure vessels are classified into Class 1, Class 2, and Class 3 based on their level of danger and hazard. The basis for this classification is pressure P, the product of pressure and volume PV, and the degree of hazard posed by the medium. Class 1. Pressure vessels, low-pressure vessels containing non-flammable or non-toxic media, low-pressure separation vessels, and heat exchange vessels containing flammable or toxic media. Class 2. Pressure vessels, medium pressure vessels containing any medium, low-pressure reaction vessels, and storage vessels containing flammable media or media with moderate toxicity. Low-pressure vessels containing media with extreme or high toxicity. Low-pressure shell and tube waste heat boilers. And glass-lined pressure vessels. Class 3. Pressure vessels, medium pressure vessels containing media with extreme or high toxicity, and low-pressure vessels with a PB design, pressure multiplied by volume, greater than or equal to 0.2 megapascal cubic meters. Medium pressure reaction vessels containing flammable media or media with moderate toxicity and a PV greater than or equal to 0.5 megapascal cubic meters. Medium pressure storage vessels with a PV greater than or equal to 10 megapascals cubic meters. High and medium pressure shell and tube waste heat boilers. And high pressure vessels. In this class, we learned about special equipment, its characteristics, and the classification of pressure vessels. That concludes this section. For your reflection after class, why do containers holding toxic, flammable, or explosive substances automatically fall into a higher classification category? Please explain this in relation to safety management requirements. Alright, that concludes this session. See you in the next class.